Dear students, today we are going to discuss earthing. What is meant by earthing? Why we have to make earthing? And what are the different types that are available for doing the earthing that we are going to discuss in this session. First, let us see what is earthing. Earthing is nothing but connection of body of the electrical equipment to the earth by using a wire which has negligible resistance. So by using a wire with negligible resistance, we are going to connect the body of the electrical equipment to the mass of the earth. Okay, this connection is known as earthing. This type of connection brings the body of the equipment to the zero potential during the electric shock. Therefore, we can avoid from shock. Why we have to make earthing? So the necessity of earthing is to protect the human beings from danger of shock. So whenever there is a possibility of leakage current and when you are touching the body of the electrical equipment, if the leakage currents are passing through the body of the human being, then he will get shock. So that leakage current can be passed to the ground through the earthing process. So we will be protected from the electrical shock. Okay, and it guarantees the safety of electrical appliances. So as the leakage currents are passing through the earth, it gives safety to the electrical appliances also, and it provides an alternative path for leakage current. Through the earth, whatever the fault currents or leakage currents that are going to be developed in the system due to some insulation failure, something else, they are going to be passed through the earth through this earthing connection. And it also protects the electrical system and buildings from lightning strokes also. And it avoids the risk of fire due to short circuits or something else, which leads to the high currents. Next, what are the different types of earthing that are available? Generally, we are going to implement two types of earthing. One is plate earthing, another one is pipe earthing. Now, let's see the first type, plate earthing. In plate earthing, we are going to dig a pit having a depth of 2 to 3 meters near to the building into which we are providing the earthing. Okay, at the bottom of the pit, a copper plate or a GI plate having dimensions 60 centimeters by 60 centimeters by 3.18 centimeter is going to be placed, and surround this copper plate we are going to make a layer of charcoal. This is copper plate, and surround this copper plate we are going to have a charcoal layer, and surround that we are going to place common salt layer. Okay, so this is copper plate, white color, and this light dark color is charcoal, and the outer layer is common salt. And the earthware is above the ground level, and we have dig a pit around 2 to 3 meters and have placed in the copper plate. In order to join this, we are going to use a GI pipe. Through the GI pipe, the earthware is passed onto the earth plate. At the earth plate, it is going to be connected to the earth plate by using some bolts, and there will be a funnel arrangement. Through that funnel, in order to increase the effectiveness of the earthing, we are going to pour salt water periodically. So this is the arrangement of plate earthing, and the earthing efficiency is going to increase with the increase in of plate area and depth of the pit. You now basic under basic design we are going to use 2 to 3 meters depth only, but based upon requirement and the amount of current that we have to make earth, you can go more depth also. And with the increase in plate area 60 by 60 by 3.18 previously we have discussed, so if you in further increase the area of that plate, then the effectiveness of the earthing is going to increase. And the depth of the pit, how much depth we have to dig, either 2 meters or 3 meters or 4 meters or 5 meters, it depends upon the resistivity of the soil. And coming to the disadvantage of this method is there will be possibility of discontinuity of earthware from the earthing plate. Generally, we are placing the earthing plate at the bottom of the pit and we are going to completely enclose that with charcoal and common salt. So, and up to the ground level. So, we are not able to see whether the earthware is still connected to the earth plate or not. Sometimes it may be broken, the connection may be broken. That is the only disadvantage with plate earthing. Okay, this is plate earthing. Next, the second type is pipe earthing. In this method, instead of a plate, as we have discussed in previous type, we are going to use a GI pipe of 38 diameter. So this is the GI pipe. This is GI pipe. This GI pipe we are going to use for earthing, and it will have a length of around 2 meters and with 12 holes. On this pipe we are going to have holes with diameter of 12 and it is placed vertically into the ground at a depth of 5 meters. Okay. Next, this pipe is going to act as an electrode and the ground wire is connected to this electrode depending on, through a GI pipe, and depending upon the conditions of the soil, resistivity of the soil, the length and depth of the pit is going to change, similar to the plate earthing. And after placing the electrode, the remaining surrounding pit area is going to be filled with layers of common salt and charcoal in alternate way. First salt, next charcoal, salt, charcoal, salt, and charcoal. Like that, we are going to fill the entire pit. And again, here also, we are going to provide a funnel so that we can periodically pour the salt water in order to increase the efficiency or effectiveness of the earthing. And the advantage of pipe earthing as compared to plate earthing is we are going to connect the earthwire to the electrode near to the ground level, above the ground level, so that we can identify whether the earthwire is connected to the earth electrode or not. So periodically you can check that connection. If there any wrong connection, if any connection is broken, automatically you can make reconnection. But it's not possible with plate earthing. Okay. The schematic arrangement of pipe earthing is shown here. This is the GI pipe and GI electrode, and here through the GI another GI pipe we are going to connect that electrical wire to the grounding electrode, and it is filled almost, here it has shown 4 meters, around 4 to 5 meters depth. We are going to place that electrode, and this is a funnel. This arrangement is funnel. This is the electrode, GA pipe through which we are passing the earth wire, and these are the salt layer, coal layer, salt layer, coal layer, salt layer. Like this, we are going to alternately fill the remaining surrounding pit of the surrounding pit. Okay, this is pipetting. And the contact surface of GA pipe with the soil is more compared to the plate. As compared to the plate earthing method, the electrode contact area with the earth is going to be more here, so that more amount of current can be passed. So this type of earthing can handle large leakage current as the contact surface area is more, and the earth wire is connected to the GI pipe above the ground level. So that already we have explained in the previous slide. So the earth wire is connected to the electrode at the above the ground level, so that we can periodically check whether the connection is broken or not. And the only disadvantage of pipe earthing is the pipe length has to be increased sufficiently in case of soil of high specific resistivity. If the soil surrounding the building is going to have high specific resistivity, then we have to increase the length of the GI pipe. So that will result in increase in cost. Okay, that is the only disadvantage. Based upon the soil resistivity. If soil resistivity is specific resistivity is more, then we have to use more length of the pipe. As more length of the pipe is going to be buried into the earth, the cost is going to increase, and the work that we have to make in that process is going to increase. Thank you.